Hey, this is Jason from Solar Batteries Online, here with Bradley and his wonderful new batteries, Australian-made product.
Yes.
LFP Lithium, the PowerPlus
Energy.
PowerPlus Energy, exactly. So, yeah, we've got 24 volts, 48 volt, 120 volt batteries made right here in Melbourne.
Most definitely. So,
Tell us
yes,
a little bit about them.
well, we started out on the lithium ferrophosphate battery design a few years ago, primarily because there was a need for batteries in high temperature applications for road traffic control and communication sites. And because we've developed these batteries for 48 volt DC, they've become very popular with solar applications. And so over the last couple of months, we've brought all of what we've learnt with batteries together for a new product, which we're proudly manufacturing here in Melbourne. So the metalwork, the assembly, the testing is all done here in Melbourne. And some of the advantages or the changes we've brought to the batteries are the low profile amphenol connectors. We've got some alarm contacts, and the modular format is proving to be quite popular, because as you can see here, we can get up to 66 kilowatt hours in a standard 600 by 800 cabinet, or we can put them in an outdoor enclosure for IP65 type applications.
Great. Yeah, so what you learned about the design from the Gen Z product, you brought to this.
So we've had a very successful 2 years with the Gen Zs, predominantly with off-grid and hybrid applications. And
yeah, a lot of the feedback I get from installers is that's the only lithium product they'd use off-grid because of its reliability.
Yep, no, they've been very good. The advantage with the approach is as a lead acid replacement. So each battery has its own BMS board inside the battery. So the battery behaves as a lead acid battery, but with the advantages of lithium. So as an installer, all you need to do is program the charge voltage, the float voltage, and the charge current, and then the battery does the rest. So if you're installing the inverter, you don't have to learn new protocols. You don't have to maintain a communications connection between the battery and the inverter. The other thing that's proven popular is that a 3 kilowatt or 3.3 kilowatt hour battery can deliver 3 kilowatts. So if you have to design for surge ratings, you're using an inverter off grid, you're not limited by the size of the battery. And as you add more batteries, it linearly increases your capacity and your surge rating.
Yeah, that's that whole limitation with the older technology like lead acid, where you just can't throw in extra batteries, where we can add on.
Well, see, quite often when a customer might start out with, say, 10 or 20 kilowatt hours of battery capacity, but in a year's time they want some more batteries. Because each battery has an individual BMS, you can add more batteries at any time. If you have a fault with the battery, if you have 24 2-volt cells, 5 years down the track, having a faulty battery can cause problems in when you try and replace one of the cells. With the lithium, each battery pack is independent, and so you just turn it off, unplug it, pull it out, and after it's repaired or replaced, slide it back in again.
And there's been quite a bit of demand in the market for a 120 volt solution.
Yes.
And that'll partner with Selectronic.
Most definitely. So we've got the 120 volt model. It's the same physical size. So you can just parallel the 120 volt batteries to achieve the capacity that you require.
Fantastic.
Now the other feature that is attractive for people that traditionally would have used lead acid is the temperature rating. So the cells will operate quite happily up to 60 degrees or 65 degrees. The battery will go to sleep at 65 degrees. Up to about 45 degrees, occasionally there's no degradation in the performance of the cells. And so whereas with a lead acid battery at 35 degrees, it halves the service life of the battery.
Yeah.
So that,
especially with Australian hot conditions.
Other feature that's very attractive for end users is that a lead acid battery, its efficiency changes depending on state of charge. So the efficiency at best is around 80%, and in that top 20% it can drop off to 50 or 60% efficient in charging. So not all of your PV is going into your battery.
Yeah.
Whereas with a lithium ferrophosphate battery, you're looking at around 96% plus efficiency charging through the whole cycle. So
less use of the generator as well.
if you do have to run the generator in an off-grid situation, you're running the generator for a short amount of time to get the same charge back into your lithium batteries. So if you're in poor weather, most of your PV is going into the battery.